Beth yw'r hafyd mi, dim ond gaia llwfod a gransi. Gariad bach cilion ffôn, gariad bach cilion ffôn.
On Earth, life is abundant. Almost immediately after its formation, life arose on this planet. The Earth is about 4.5 billion years old, and for the vast majority of that time, life has been present here. For over 3.5 billion years, life has risen, grown, and flourished virtually everywhere. Life on Earth has proven itself to be a powerful and determined force, overcoming all manner of adversities, climate and planetary changes, and catastrophes. It seems that no matter what the universe throws at it, life on this planet finds a way to adapt and grow. Given the tenacity of the life on this planet to survive, it is a natural question to ask if this could happen elsewhere in the universe. If what we have seen on Earth is any guide, the answer would seem to be that life elsewhere is almost a certainty. We have found life near volcanic vents, on Arctic ice sheets, and in the deepest depths of the oceans. These observations of organisms in hostile conditions support the idea that life can thrive anywhere in the universe, not just here. If anything, life seems determined to develop anywhere it possibly can. Humanity is at the pinnacle of life on this planet. For roughly 30,000 years, we human beings have struggled and fought our way up the food chain until finally, we created civilization. But civilizations rise and fall in the blink of an eye when viewed from the perspective of the stars. For example, one of the most successful civilizations on this planet, the Egyptians, lasted only 4,500 years. The Greeks, about 1,000 years. And the Romans were around for roughly 1,500 years. All of these cultures were born, thrived, and died in a minuscule moment of cosmic time. Compared with how long the stars have been around, our civilization is not even on the radar screen. The search for life elsewhere in the universe can be approached in two ways. We could look for civilizations, which are tiny, brief, shining moments in the lifetime of a planet. But that approach is hard. It would be like searching for a spider in a giant auditorium when the lights are on for only 1 second. The chances are very low that we'd succeed. Looking for a civilization on another planet is the least likely way to find life. The second approach is to look for any and all life, including the simplest microbes, the most tenacious and longest lasting form of life that we know about. Microbial life has been around on our planet for roughly 3 of the 4.5 billion years our planet has been around. That is not the blink of an eye. Finding microbial life is much more likely, so we should begin our search there. To mount a serious investigation for life elsewhere in the universe, we need to narrow our search and make a more systematic effort. And the first place to start? We need to find some planets. As of January 2006, astronomers have found about 170 extrasolar planets in our galaxy. These are planets orbiting other stars, and they have been found, for the most part, using ground-based telescopes. Most of the extrasolar planets found have been large, Jupiter-sized ones, not the ideal place as far as we know to harbor life. We need to find planets more like the Earth. In June 2008, NASA will launch the Kepler spacecraft, a high-resolution telescope designed to look for smaller, Earth-sized worlds. It will look for extrasolar planets by measuring how the light from the star dims as the planet crosses between it and the telescope. By measuring the drop in light, we can infer how big the body was that passed in front. It has on board a very sensitive detector designed to measure extremely small fluctuations of light from a star. From Kepler, we hope to find the first candidate worlds that warrant a closer look for the possibility of life. Humanity has risen to the pinnacle of life here on Earth because of our intelligence and critical thinking skills. These tools have helped us overcome all manner of adversities thrust at us. We also have an insatiable curiosity, and this quality, perhaps more than any other, is responsible for the rapid pace with which we have grown. It has allowed us to ask questions and build technology that we have not seen anywhere else. But it also makes us lonely. We seem to be driven to answer the question, is there anyone else? If we can find one microbe on one rock, alive or fossilized, if we can find one tiny colony of bacteria hidden in an ancient meteorite that we can prove came from an extraterrestrial source, then we will know there is life elsewhere in the universe. And if life is in that one tiny rock, then it's everywhere.